So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about the newly released InContext Design tools that we've announced for Onshape. As I always say with these webinars, I really encourage you to ask any questions you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question. Going to be a short webinar. We're really just going to focus on these new techniques and ways to use them. Now, let's dig into it. One of the first things I want to mention, of course, just a brief agenda. I want to do a simple introduction into InContext Design. So if you're not familiar with InContext, if you've never done it in any other CAD application, I will give you a simple introduction into what it is and how it works, and then also briefly discuss where you might use some of these tools that we're going to discuss here today, where they apply most. Of course, we're going to show you how it's done in Onshape. I'm going to walk you through a couple of examples of it. And then I also want to take a moment to discuss some of the advantages that we have over other CAD software. And I think that there are a lot of users out there that are naturally hesitant to adopt any kind of in-context design because of the instability of references in traditional file-based systems. So I want to discuss some of the advantages that we have over something like a traditional file-based system like SolidWorks or Inventor when we talk about in-context design. Now, as I mentioned before, feel free to ask any questions you'd like. There's a questions dialog in the GoToWebinar control panel, and I'll do my best as we're going through things to stop and address the questions from time to time. All right, so I do have one quick question for the audience, so bear with me for just a second here. And especially useful in today's webinar, because I really think in-context design is something that you do, as a more advanced topic than a lot of users may ever get into. So I'm really interested in, of the audience here listening today, are you using Onshape for professional use? Are you interested in using Onshape for professional use? And I think that's a big part of, the audience today. I just suspect, just because of the complex nature of in-context design, it's not something that a new user typically has a lot of questions about. So just curious, are you interested in Onshape for professional use? Or are you using Onshape today for professional use? Let me know. We'll close that one out. It looks like, as I mentioned, a large majority of the audience is here using Onshape for professional use, which is great. This is definitely one of the more advanced tools that we can have in a CAD system, and I think that's the key audience. So let's close that one out. Now, as I mentioned before, we're going to have a brief intro. I want to get into, what in-context design is, how it works, where you might use it, and some of the things to watch out for. So let's get into it. Now, what is in-context? If you're not familiar with the term, it just means you're building parts, you're modeling parts with contextual relationships to an assembly. So if you think of a traditional new user who's just getting started in a CAD system, they're going to build what's called bottom up. And that means building each part in isolation, one part at a time in their own separate tabs, so to speak, in an Onshape document. And there's nothing wrong with this approach, but it has a lot of limitations when we start talking about more complex assembly design. So in short, when you need to start building parts with relationships to one another, that's where in-context becomes critical, right? If you have a simple design where, the parts can be modeled entirely in separate spaces, there's no clear advantages to it, then there's not a lot of advantage to in-context. So it really comes into, how complex is the design and, does it lend itself well to that? Now, the question inevitably comes up, well, you have multi-part part studios and you have in-context assembly design. Which one should I use? Which one is best? And the answer is there's not always a clear answer. It just depends, some on the preference and some on the scenario. For example, if you've already built an assembly, the choice will be made for you, right? You'll need to build in context. Also, if you find yourself importing a lot of sub-assemblies, maybe you're getting sub-assemblies from other CAD softwares, then in-context becomes a must, right? Or you could consider translating and all these crazy steps to bring it into a part studio. In-context just makes more sense. So you do have options. I do want to point this out. If you want to build multiple parts together, you can do it in the part studio. You can do it in the assembly. It's entirely up to you. I think for designs that have a lot of motion, a lot of moving parts, and geometry relative to those moving parts, If you think about, if I have this moves to a certain position and I need a feature that does this, and I have all these positions of the assembly and geometry that needs to reference it, InContext is the way to go. But if nothing really moves and, things are real simple, or not, I shouldn't say real simple, but, things don't move in complex ways, multi-part part studios are fine. So you really have options. And in some situations, like I mentioned, if you're importing assemblies, then the choice will be made for you. But just realize you can model top down either in the assembly or in a part studio. And when I say top down, I'm referring to InContext. You'll hear me use those words interchangeably, but really they're both industry terms for building with relationships to one other, to other parts. Okay, so again, short explanation. You're building parts that are tied to other parts with contextual relationships. And these relationships come from the assembly. If you've heard of the term top-down design, that's another term for in-context design. They'll kind of mean the same thing. The big thing, though, is it makes building relationships between parts in your assemblies easy. And the question comes up, well, why would I bother with all this? It's technically possible to build each part separately. Why would I take the time? And the answer is it's just a lot faster. If you find yourself building parts in a bottom-up manner, taking dozens of measurements and figuring out all these dimensions and then having the possibility for all these mistakes, you'll quickly realize building things together has a lot of advantages. So that is a short intro into in-context design and why you would consider it. Okay, so just consider the fact, you have a design, moving parts, and they all have relationships that need to be defined relative to one another. So that's a short intro into InContext. Now, where would I use this? Well, again, anytime you want to relate one part to another in your assembly, and that's an important caveat there. You can relate one part to another if they're both in the same part studio very easily. But if you want to relate a part in your assembly to another part in your assembly, then you'll need in-context design. Now, you can also create a new part that joins two parts in your assembly. This is very useful for designs where you're not sure of the measurements or it's not really clear what the certain distances or dimensions are going to be in the part. You can build it with references to the things it's attached to. So you can edit parts in the context of the assembly, and you can also create parts, new parts, within the context of the assembly. Now, the example I'd like to give, and I think it's a common one, is imagine you needed to create a feature that's tied to certain positions in an assembly. The example I have is that folding step stool that you see. And, open and closed positions is going to need certain features, certain cuts to the geometry to match those open and closed positions. So it's very easy using InContext to go to that position, create a context, and then actually get geometry from it. And it's a useful way to design. Question, 2 or more parts in an assembly. Absolutely, you can have as many parts in the assembly as you'd like. Okay, so where would I use it? Again, anytime you want to relate one part to another in an assembly, anytime you want to create a new part that's contextually tied to maybe two other parts, and create a feature that's related to different positions. And I think these are all good examples of using in-context design. All right, so enough slides. Let's get into it. Now, I'm going to start off simple. I want to walk through a basic example of in-context design. And then I want to show you kind of what's possible down the road when you start to really get into some of the potential of this. So let's start off real simple with the pedal box. And this is an example where I have an assembly with several sub-assemblies that I've imported. And oftentimes you don't have control over that. If you import a sub-assembly, that's what you have to work with. And in the past, users have done all these crazy workarounds to bring that sub-assembly into a part studio. Now you don't have to. Now I can work right inside of the assembly context. So I have this pedal box design, and it has a certain range of motion, right? So these pedals are free to move, and if I go in, I can define the range of motion for each pedal, right? So I have 30 degrees of travel in each one. Now that becomes important because in my base plate that these pedals attach to, I want to define stops. I want to have clearance cuts for these sub-assemblies that exist, right? All of that needs to be done within the context of the assembly. So a good example where my options, are pretty limited here. I have sub-assemblies I want to build in context. question. Does InContext Design update all your design history? How about working drawings? Yes, absolutely. Every InContext edit is no different than a normal edit. You're going to see the changes in history. If you update a context, it's a step in the history as well, which means it can also be restored. So you don't have to be afraid of breaking things like you would in a traditional file system. You just remember that any change that you make, delete a context, add a context, edit a context, you can always restore. So you never have to worry about breaking it, so to speak. And of course, any change to the part is going to update in the drawing, right? As soon as you click the update icon. So just keep in mind, you get all the benefits that we've always had with Onshape. You're not sacrificing anything to design in context. Now, I want to mention a few things in particular, and if you've come from a traditional, file-based system where InContext was a scary or dangerous thing, there are a few things that I want to emphasize here. First off, it's not using, of course, any file-based traditional way of capturing that assembly. What we do is we capture a snapshot of the assembly and bring that into the Part Studio so that you can continue modeling. And you can model around all the pieces of your assembly within the context of the Part Studio. So one of the things I want to stress here is that, again, all of your part modeling is still done in the Part Studio. We're grabbing a snapshot of the assembly and bringing that in so that we can model around it. That's really the way to think of InContext in Onshape. We're grabbing a snapshot of the assembly, all the parts, their orientation, and bringing that in to your Part Studio. All right, so I want to design a few cuts, a few manual additions, let's say, to this base, to accommodate for the cylinders, to accommodate for this pedal, and I want to have an actual stop designed in the base so that the user can only go to 30 degrees and then it hits, right? So it actually hits a stop and can't go any further. Of course, I also need to create the cuts in my plate to accommodate for these subassemblies, right? These cylinder subassemblies. So we're going to do both of these changes in context. Now, how do we get started? The easiest way, one of the easiest ways to create a new context is to right-click the part that you want to change. So for example, if I right-click this base plate that all these parts are attached to, if I right-click it, you'll see the option to edit in context. As the name implies, this will start the edit in context process, right? So I click edit in context, that will drop me back into the Part Studio. So again, just stressing that all the part modeling is still done in the Part Studio. It's just grabbed a screenshot of that assembly and brought it in with it. And the useful thing there is, of course, now I can reference anything on it. So you can see the Part Studio has the pedals and the base piece, but it doesn't have the cylinders. And so what you'll see is kind of a ghosted image of the assembly. And the assembly here has all of the cylinders. Of course, I have my pedal in that all the way down position, right? So I'm seeing the assembly ghosted in my Part Studio. And it's ghosted, but it's just as useful as any other geometry. I can reference the edges, I can start a face on, or I can start a sketch on the face, any of those things that you'd expect to be able to do. But remember, this is just a screenshot, I shouldn't say a screenshot, a snapshot, right? It's a snapshot of the assembly at the moment I clicked edit in context. All right, so now let's take the top plane, let's start a sketch. And the first thing I'm going to do is create those cuts in my base to accommodate for these pneumatic cylinders, right? So I'm just going to create two simple rectangles, and I'm going to dimension them relative to my cylinders, right? So now I'm adding a dimension relative to my cylinders. I hit 5, enter. Now I have a 5 millimeter offset. Now something very important just happened that I want to stress. You don't actually create a context until you create a relationship to something outside of your assembly. So all those steps up to this point, edit in context, starting the sketch on the top plane, they didn't create a context. Adding a dimension to something from the assembly creates a context. And you may have caught it there, yellow banner here, context 1 of pedal box. So it's now telling me I'm in a context, and you'll see assembly context in the top left corner. This is how you access those contexts, turn them on and off, and so on. So we've now created a context to the assembly. One other indicator, you'll notice the arrow in the feature, the sketch or the feature that has the contextual relationship will display an arrow indicating in-context references have been created in that feature. And so now, again, I'm really applying geometry no differently than I would if everything were in the same part studio. So it's really no different than, if I had brought all of these cylinders in. They come in the same position and so on. So we can add a few dimensions, of course, tie these together, and define our sketch. Now, I can convert entities. I can do all the same things that I'm used to. So again, treat it no differently than you would a normal sketch. The only real difference is you have those context relationships to the assembly. Okay. All right, so now we have our fully defined sketch. My goal with this was always to create a cut. So we'll create an extrude, remove, and we'll do through all in both directions. Okay. So now I've created my cut. I hit the green check OK, and now I can see I've created the necessary cuts for clearance for those cylinders. A few questions that I'm seeing here. How fast are the updates to the web browser when using large assemblies? Once the data is loaded, there should be no performance difference specific to the assembly. Are the in-context snapshots static geometry, or do the components of the assembly move? They do not move, and that's a good question. Are the in-context snapshots static, or do the components move within the context of the part studio? The answer is they do not move. They are static. Okay? Now, of course, in the assembly, they are free to move, but not in that part studio, not in the in-context environment. Can I create parts within the context of the assembly on the fly? For instance, creating a blank assembly with 5 parts. Yes. I'm going to show you an example in a bit where you can create new parts within the context of the assembly, from scratch. So not editing an existing part, but creating a new one. And this also opens up potential for other things too, like layout sketches. A lot of users like the ability to have one sketch that drives many different parts, and you can do something like that at the assembly level now within context. So all kinds of very cool potential with this new capability. Can in-context design be made through multiple assembly levels? You can have as many contexts as you'd like, to as many things as you would like. So I'm going to say yes. I can reference multiple assemblies, reference multiple different things in a single part. And that's something I'm going to mention in just a bit too. You can have more than one context. And I can edit multiple parts with one context or multiple context. So think of any scenario where you have, 5, 6, 10 positions. And for every position, you have this certain feature that does this certain thing. You can go to each position, create a context for each position, and then edit your geometry accordingly. Right? And that's something that's always been tricky when you talk about file-based systems, breaking references or all these types of things. Can a part participate in multiple contexts? Absolutely. Yes. Okay, so now I have my first cut made in context. Again, you'll see that sketch 6 showing that indicator that it's an in-context reference. Next, what I'd like to do is create that cut, create the boss that this is going to rest against. I want to create a stop for the pedal so that it can only go so far. And in this example, I'm actually going to use the face of the pedal to start a sketch, right? So I'll use the face of the in-context pedal from the assembly, start my sketch there, right? Normal 2. And I'm just going to use this in-context geometry as if it were normal, right? I select the edge, I hit convert, just as if it were a part in my part studio. I can start sketching in geometry pretty quickly here and define that stop. Okay, add a few constraints to define things, and I'm off and running. Okay. Again, the thing I want to stress, though, is I'm referencing the pedal at that position. Right. So let's say I want 40 millimeters, and this 15. There we go. All right, so I've got a fully defined sketch. referencing the face of the petal, I click extrude, then we'll reverse, right? And we'll say up to next. And it's going to extrude into my frame here, right? I hit the green check, and now I've created that second InContext feature. So you'll see Sketch 6 and Sketch 7 both have InContext references. And now I know I have the perfect position for that travel in my assembly, right? So let me jump back to the assembly. This is definitely one thing that I wanted to stress. If you're, again, familiar with a traditional file-based system, you know that moving the parts is one of the more common ways to break it. If you have InContext Design and everything's relative to one another, when you move things, they all update dynamically. But really, if you think about an example like this, I wouldn't want just a drag up to cause the geometry to rebuild, right? If I grab and pull on this and move it up to the 0 position, I don't want the boss to automatically update to match that new geometry. That's not my intent. So the idea behind Onshape's contextual relationships is they don't change until you decide to change them. That means you'll never have a scenario where you open it up and everything's just red and broken. It will remain in that position, that state, so to speak, until you decide to update the context. So I can, move this any way I want. I can move any piece tied to anything that I want, and it doesn't dynamically update that geometry. Now, of course, you will have scenarios where you need to update the geometry, and that's where we get into updating the context. All right, so a few questions that I've missed. Can I break said context after the fact? Let's say that I have a part that I want to add to other projects in scale. Yes, you can delete the context. It does not cause the geometry to fail. You can then go in and add proper constraints, later if you choose to. But my point is, again, it won't just fail, to rebuild if you break the context. You delete the context, I should say. And you can do that. I'll show you this in just a second in that same assembly context drop-down menu when you're editing in context. Can I update all the context of projects once to be sure that the change at the top level propagates to all components that reference it? And I believe the answer is going to be no in this case, and only because there may be several contexts referencing one another. So I'm fairly certain the answer to that's going to be no. Presumably, you can hide unwanted parts in the assembly before creating the context. Yes, and this is a very good tip. When you create a context, when you right-click that part and you say Edit in Context, it takes a snapshot of the assembly as it exists at that moment. Right? So all the hide show states of the parts, the positions of parts, very important. Make sure that you have the parts positioned properly, you have parts hidden or shown that you want in your context, and then edit in context. Okay, so a very good tip. I'll probably mention that again before we finish things up here. Is an in-context feature in a subassembly visible at higher level master assembly, or do you need to go back to the subassembly to change and update it? I believe you can update the context of the assembly of a subassembly from the top level. Yes, you should be able to update the context of a subassembly from the top level. I would need to try that to be 100% certain, but I'm fairly confident of that. Why are we seeing two petals? Why are we seeing the difference in two different positions? It's important to point out this part studio had the petals in it. So here I'm actually using a combination of multi-part modeling. You can see my frame here is one part and each petal is a separate part. And I'm using InContext Design. So this part studio had the petals. So when you go in and view the context, it's just showing the position of the petals at the assembly. Okay, but it's important to point out the part studio had the petals beforehand. And so I'm actually using a combination of multi-part and top-level design. All right, so now that we're here, I'm in the part studio. This is the part studio called Frame, which has the petals and the frame for the design. It's important to point out once you have a context, you can choose it from the drop-down menu. Right? So I have none, I have context 1, and if I click context 1, it will load the context so that I can keep working and do whatever I need to do relating to that geometry. But if you don't have to create references to a context, you can always just set it to none. Now, another big tip that I have for you is, especially when we start talking about multiple contexts within a part, I would definitely recommend renaming your context. What I mean by that is in the drop-down, or excuse me, in the ellipsis menu next to the drop-down, you'll see an option to rename. As you get more and more context, it's not going to be as clear, what's the difference between context 2 and 3. But I may have an open and closed position. So if I rename it open and closed, it's very easy for me to understand, which context I'm updating or making changes to. Now, if it's just one context, this probably isn't as critical, but I would say renaming is a good habit to get into, renaming the context in general. Now, also, the question came up earlier, can you delete? This is the option to delete. It does not break anything, so to speak. You will get a visual cue that the sketches are referencing a deleted context, but the features themselves don't fail because of it. So you can go in and edit features or just leave things as they are if you choose to. So we really tried hard to build a scenario where it's nearly impossible to create a scenario where it just opens and it's broken, right? Contextual relationships don't live update, just for that sake. All right, so this is the assembly context, and you can load it in the Part Studio. I'm looking at the Frame Part Studio. Question: can you set the pedal at a specific angle in order to create the new feature? Yes, you can edit the mate. Now, one tip that I have for you, let me jump back to my assembly real quickly for that question. In this case, it's very simple. I have a revolute mate that defines the pedal, and I just set whatever angle I want, right? So this has a min-max of about 30 degrees, and I can change that. So let's say that, for instance, I wanted 2 degrees less travel, right? Now, of course, what that means is our stop, the feature that we designed a moment ago, is no longer relevant, right? It's not going to be useful because, of course, that we want it 2 degrees shorter. So now I've changed the amount of rotation so that the stop is at 28 degrees, or excuse me, the pedal is at 28 degrees, but my stop, of course, hasn't updated to accommodate for that. So the question then comes up, well, I understand that it's not going to live update. How do I update it manually? And the answer is just to right-click and update the context, right? And you could do this from the assembly level, or you could do it from the Part Studio level. So if I right-click the frame, let me get in close here so you can see. So again, the problem there, we've updated our limit. We now want to update the context that this frame was built in. Now, an important tip, as I mentioned before, notice the orientation of your parts. If I wanted to update the context, I wouldn't do it with the part in this position, right? I want to make sure that it's in the same position that it should be for that contextual relationship to be created. Then I right-click the part, and I choose context, whichever context it is, and this is why naming the context becomes big. And I just say update context, right? It will go through and look for the geometry change and update accordingly, right? So now you can see that the geometry has been updated to match the new position of the pedal, okay? So that's updating context. Now, you can do that from the assembly, just right-clicking like I did a moment ago, or you can do that from the actual Part Studio. And in the same, the behavior is the same, but again, you can update context here as well. All right, so question: can I use reference geometry in context like planes or coordinate systems as reference? Yes, in the Part Studio, you can use anything as a reference. So you can use any planes or coordinate systems created in that Part Studio as reference. Forgive me if that's not answering it. Would you want to isolate coupled with InContext, especially on larger assemblies? That can absolutely, it can help, yes. And I would say, again, just make sure that you have the appropriate parts hidden or shown. Isolate is a good way to get that quickly, but whatever techniques you prefer, make sure that you have the right part showing and in the right orientation when you either edit a context or update it. Those are the two stages where it's really critical. Okay. Is there a compare tool for context? There's not a specific compare tool for context, but Trying to think of a way you can use the current compare tool to accomplish this. I don't know off the top of my head. That's a good one. I have to think about that. You may be able to use the existing compare to accomplish something like that. You can compare between moments in history and versions and things. So maybe it would probably be a workaround, but I think it may be possible. So I'd have to look into it more. Can I update the context once I have it set? Snapshot taken. Absolutely. So again, just right-click the part. You'll see the little visual cue in the instance list, the arrow here. And if you right-click, you'll see the context name. In my case, just context 1. And you can update the context from here. But again, make sure that you have those part positions right and that the hide show state and everything's correct. Can I replace a context with another that I've created? You can. It's not replacing it. It's deleting it and recreating it. But that's how you do. Delete one context, delete its constraints that are tying it to something else, and then recreate a new context. Can you change the opacity of the ghosted parts in context? No, that's not an option as of today. I will say that's been brought up before, so it wouldn't surprise me to see that in the near future, but it's not, again, it's not there today. Can I set a context update automatically? No, and that was a deliberate decision only because of the volatile nature of it. We wanted something that updated in a little bit more predictable manner. And it's not this isn't an easy problem to solve, admittedly, but we really wanted something that was stable. That was priority number 1 for us with this in context. What about drawing? Start immediate and final positions in a view. No, not yet. But I will say that's another highly requested one. So just a tip, you can create named positions in the assembly, and this will help for in context, but they're not yet usable at the drawing level. Can you show how to add parts to the new feature, i.e. add 2 bolts to the feature created? I will show you an example in just a bit where you can add new parts on the fly, yes. If we set the positions of the parts in any assembly or in an assembly suitable for context, then move them a lot to make context 2, then we decide we need a small change to context 1, can we reset the assembly to like context 1? Well, you can update it to the position of context 1, absolutely. Yeah. So you can always go back and update a context. There's no harm in doing that. It's just, of course, it's going to grab the position of everything at that moment. So if you decide it shouldn't be right or the context is wrong that I created initially, move it into the correct position and then update the context. And then it's going to push those changes into the part. So yeah, the contexts are not written in stone once you've created them. It's just they can update it when you choose to. Question: if I have dozens of in-context components in top-down assembly, can I see the list of components that are not updated? No. There's not a visual cue as of today that they're not up to date. You can see the list of things that have contextual relationships, but it's not going to show you dynamically the list of date or not. As a workaround, can you superimpose overlay views? I'm sure there's lots of workarounds that users can discuss. That may be one. Of course, this is something that we're going to have in the near future, so hopefully very soon. Are context updates stored in the history? Absolutely. So if I go into my history, show changes, you're going to see update context as a step. The thing that I want to stress with this is you can go right before that and restore. So don't be afraid to update the context for fear that you're going to just, everything's going to break. When you update the context, if something doesn't behave the way you want, just restore to the point just before that, and you're back to where you were a moment ago. So again, with history, you don't have to worry too much about breaking things, and that was a big concern. Can we create position states and name that position? Absolutely. So that is a very good segue into the next one. Now, the questions come up, especially when we start talking about assemblies, is, well, what if I have multiple positions? In the gas pedal example, we had an up and down position, and something like a step stool, we have an up and down position, or a folded and closed position that we have in our assembly, and you may need to easily get between positions. Now, this really has nothing to do with InContext, but it's very helpful for InContext, and that is creating a named position. This is actually brand new. We added this, I believe, last week. So it's only a few days old now. But the neat thing is it allows you to capture a position of your assembly. So this is the stool open. That's the stool closed, right? And I can test out both positions. I can get to both positions very quickly. So I can't recommend this enough when we talk about in-context design, because it's a very easy way to get back to an exact position. Especially useful for creating context relationships from creating the first, or updating context, right? Because you want to make sure that you get all the parts back to that same position repeatedly. So named positions, this is useful outside of InContext. It's useful everywhere in assembly. So, just a good tip, but especially useful for InContext design because it makes a repeatable way to get back and forth. Okay. All right. So what I'd like to do is go through a few tips that I have for multiple contexts. And I mentioned this before. You can have more than one context to your assembly, more than one reference. And this is something that's particularly troublesome when we start talking about a more file-based traditional system. So let's take a look at this. What I'd like to do is give you an example of how we might put something similar together, like this folding step stool. And the folding step stool has a few important key things that really relate to the motion of it, right? If we think about it, we need a cut in the frame that matches the movement of the assembly, right? So I need to make sure that matches appropriately. I also need to make sure that the cut in the chair, right? So this cut in the seat, I should say, matches and lines up perfectly with that moving part, right? So that I don't have any kind of issues with lining up. Now, in this example, it was built entirely in different part studios. So I have all these different tabs for these different part studios, and I'm bringing them together. Now, one last thing that I want to stress with this design is it opens up, or I should say InContext Design, is it opens up one, I think, really important workflow, and that is designing around layout sketches. Because in this example, if you look closely here, the entire stool design is driven by a single layout sketch. And changing that layout sketch will allow me to build all these different size step stools. And so, I know there are a lot of users have asked this before, and we've been able to insert a sketch into an assembly for a while now. But now you can actually create contextual relationships to that sketch at the assembly level, and it opens up all kinds of possibilities. So I just wanted to, do a quick shout out to those, that do layout sketch design. This is something that you can do in the assembly level now, and it's definitely something that's very cool. All right, so let me give you a few quick examples of this. Now, the main thing I want to stress with this example, we only have about 20 minutes left here, but the main thing that I want to stress with this example is the fact that you can capture multiple contexts. So you can capture the up and down position and get it exactly right? So, for example, this is that same folding step stool frame, and I have these open and closed positions, just like we had in the finished example. But you can see that I do not have the cuts to match those open and closed positions. So I've modeled these parts separately. I bring them together in the assembly. Now I need to create a cut in this main frame piece to match that open and closed position, right? So let's do that. Now, the key thing here is I want an open and closed context, right? I have two contexts to accommodate for. Now, I've already created one for the layout sketch, and so we can just open it. Now, a big tip, again, if you've already created a context, you'll want to right-click and open that context and edit it. Don't click Edit in Context again. By default, that will take you into a new context. So a tip, if you already have a context created, right-click, open, and you'll see Edit in Context. That will take you back in to the Part Studio in that context, right? And so now I can start my sketch, right? So let's go down here, turn on plane 4, and I can start creating the sketch that's going to drive the cut that will give me the clearance so that I can move things around in this assembly. Now I'm just going to hide the large frame and start to treat this again as if it were a part in my part studio. So I can select the edges here. We will use them, convert them, and I'm actually done. Now in this example, I have my top of the range of travel. Remember, this is the open position, but I also need to accommodate for the closed position. So what I'm going to do is hit OK. we're not done with that sketch. For the moment, we're going to move on. So I'm going to show this again. And so you see sketch 5 has been created, and it's created in the context of the open position of the assembly. Now I can go back to the assembly, and let's go to that collapsed position. All right, so I go to that collapsed position. Now I want to create a new context, right? So this bar needs to have a cut that accommodates for the open and closed position. So I'm going to right click the bar, the large frame bar, and I'm going to say edit in context. We're not editing an already existing context, we're creating a new one. So I'm going to say edit in context, and it's going to bring in the assembly in that orientation. Right? So this is a separate context from the one I was editing a moment ago. Again, just trying to drive home, you can have as many, you can have multiple in there if you'd like. And so now I can go back to that same sketch. This is sketch 5. Let's hide that large frame bar again. And I can now convert the edges of the part. Same exact sketch. Now I have, one sketch that's actually driven by two separate contexts of the assembly, two different positions of the assembly. Right? And so it's really easy for me to reference that min and max range of travel because I can just move the part into that position and copy, and use it. Right? So I can convert entities very quickly and save myself a lot of time. Now, if you take the time to figure out the amount of measurements that you would have to take to do something like this, it's mind-boggling, right? Especially when we start talking about even more complex pieces like linkages between moving parts where the math is very complex, right? All right, so I've trimmed things up just because I like that neat, clean sketch. And let's do a cut. All right, so we'll do a cut. And we'll say symmetric, half inch. All right, so I've created my cut so that I can accommodate for that piece. I'll hit the green check. Now, of course, we need to mirror it. So we'll mirror the cut to the other side. Right plane. There we go. And now we have both cuts, right? So I mirrored the cut to the other side. Now I've created this context relationship to 2, right? So you can see I have several contexts, and you can have as many as you'd like. So don't be afraid to create a context for an important position in your design. So now I can say, let's go back to the assembly. And now I can test it out, right? I can grab and drag and see, okay, it's going to stop as soon as it hits that top, of course, because that's where I grabbed the context, and it's going to stop as soon as it hits that cut at the bottom. So I get that perfect range of motion because, of course, it's all driven from the assembly position, right? Now, naturally is, well, what happens if we decide, you know what, that's actually too close. We need a little bit less travel, for example. Same as before, same as the gas pedal example. So let's say that we say, you know what, it should be only 28 degrees of motion. It should stop a little bit closer, right? Grab it, drag it down. Now I have this gap where my context is not up to date with that new position. So all I do is right click and update the context. Now you can see, there it goes, the context updates to accommodate for that new angle position of the step stool. Okay. So just keep in mind, you can have as many contexts as you'd like. I would highly recommend, even though I didn't do it myself and I should have, rename your context. Rename them to open and closed or whatever position, something that helps you remember what it is. Because what will happen is, especially when you have 2 and 3, is you'll right click and you'll say, which one do I need to update again if they're just context 1, 2, and 3. Unless you have a very good memory, I would recommend renaming them. All right. Question: can I use a single context in more than one part studio? No. I mean, you can edit in context and grab the same orientation of parts, but it's not exactly. It would be exactly the same thing. It's just not the same name. Forgive me if I'm not answering that clearly. How do I get the intersection points from sketch to the upright? Well, you could take a simple measurement if all you're looking for is the number. That's probably the easiest way. But we can get into sketching in the context. I'm going to go over that in greater detail in a second. Can do in context volumetric reference. Let's say you create a surface off the copy and then do Boolean. Yes, absolutely. You can do Boolean operations. These are treated no differently than parts in your part studio. So absolutely. In this sketch, you did a sketched planar cut. Can you create a Boolean operation? Yes, absolutely. Yes. What happens now to the stored collapsed position with an angle of 30 degrees? It has been updated. Right? So when I right-click the large frame bar and I said update that context, it pushes it now. Okay. Question, did it update both of the context in that part? No, we need to update them separately. And the thing that I want to stress is you may not always need to update both contexts, right? In the example I just gave you, the open position didn't change. It was only the closed position that needed to be updated, right? So you may not need to update all contexts. It really just depends on the scenario. In this example, my open closed, only closed changed. So that it needed to be updated. Create. So it would be recommended to update the named view plus the context. Yeah, I would say good practice. A named position and the context. It's a good way to organize it. Naming them and maybe even naming them the same thing would be a great way to organize it. At least keep it clear, what you're trying to do. The features you're creating are correct, but do not address the actual machining process. Please address mods from there to change machining accordingly. Just understand that any of these, I could create a very simple cut for something like a milling machine, just clearance cuts. I wanted to show the exact stop positions deliberately, just to show that you can reference the actual edges. But I could very easily just create a clearance cut, right, so to speak, that gives me all kinds of room between the two parts. So I really just wanted to drive home you can reference the exact edges, not necessarily talking about machinability in this example. Can I have a feature script to do a button update all at once? I do not believe so off the top of my head, but I'm not 100% certain. The update of the context is done at the assembly level, and you can't use, there's no feature script function for assemblies as of yet. Now you can update from the part studio, and that's the only unsure thing I am. I'm not sure of if you can do that programmatically with feature script. So forgive me. Can you have a context for the -28 and another one for the -30? Absolutely. Yes. So you can have a position 1, 2, and 3 with different angle values. Yeah, absolutely. I would say that's going to be very common. The key thing I want to stress here is, especially when you have moving pieces and features related to those moving pieces, all these different positions, and at this position it has this boss and hole, or whatever it may be. That's where this is especially helpful. All right, now I only have a few minutes left, and I have a few more things that I wanted to mention here today. So let's move on. Now, what I'd like to do is show you how to create new parts entirely in context. So up to this point, I've shown you how to edit parts in context. You can right click a part and say edit in context, but what happens if you want to create a part entirely from scratch in context? And so right next to named positions, here's an icon, create part studio in context. So I click create part studio in context, and there's one important step before you start creating your part, and that is defining the origin. By default, you could use the assembly origin for your part origin. So essentially what you're saying here is, what is the origin for this newly created part studio that I'm making? I'm just going to use the assembly origin. A tip, though, is if you really care about a specific origin for your in-context part, create a mate connector at the point, wherever you want, and reference it when you're creating it. And that will position the part with that origin. And I know that's really critical for a lot of users, especially if we talk about downstream cam and other things like that, where the origin position is a really critical thing. In this case, I'm going to use the assembly context. I'm just going to point to the origin of the assembly. All right, I'll hit the green check. What happens is a new part studio is created. Again, remember, we're not actually building parts in that assembly tab. We're grabbing the context and then moving it into a Part Studio. In this example, the Part Studio happens to be blank. So we have a blank Part Studio with the assembly context, the complete assembly context. Now, one thing that I didn't mention, and I want to mention before I forget, is the assembly context does not care about feature order. So in this example, I'm starting from scratch with everything in my assembly. I could have easily edited the context of one of the previous parts, rolled all the way up to the beginning, and referenced it from the very beginning. So don't be afraid to roll up in your design, because it's not going to, the context doesn't care. It doesn't care if it's relative to the first sketch, the last sketch, or any of them in between. You can roll to anywhere you want and create contextual relationships. So again, just stressing, feature order makes no difference on the ability to create context references, right? All right, so now let's start sketching. I have a bit of sketching to do, so if you would bear with me. Again, I'm going to use the faces of the assembly parts as references. And what I really want is just a simple link arm that joins these two. And I can just grab the edges like I normally would, convert them, right? Maybe offset them to quickly create my geometry. And for the sake of time, we will sketch some lines here joining these and start to get our finished link arm. Okay, so now I'm building a part from scratch entirely within the context of the assembly. Right, so let's add our constraints, make sure this is a nice clean sketch. Right, fully defined, there we go. Now what I'd like to do is create the opposing link arm. And as I mentioned before, you can create one part in a context, or you can create multiple parts within that context. So I can actually, in the same sketch, if I wanted to, convert this edge, offset this circle, and construct the other link arm, right? Because again, in Onshape, you can sketch as many parts together as you'd like. And so it's easy for me to sketch a few more lines and lay out this second link arm. Okay. Bear with me for just a second here while I clean things up. And again, just trying to drive home, you have all the same abilities, multi-part abilities. You can sketch multiple pieces together, multiple features together if you choose to. And you're not really sacrificing anything by going to this in-context type technique. So I'm going to sketch a few construction lines to really tie things down here. And a circle, give it a value of 3/8, and do a simple offset. Okay. So for the sake of time, I'm going through this quickly, but again, you can spend the time to lay out all the features just as you'd like to see them. And now I've got my fully defined sketch that's driven by the part locations in the assembly. Okay. So I extrude. Okay, and we'll say we're going to extrude 0.125, and we'll click on the contours. Now, as I mentioned before, I actually have several contours here that I want to extrude, so I'm going to individually select the pieces that I need to get the geometry that I'm looking for. Right, so there's one extrude, right, green check. Now we'll show that sketch again and create our second arm off of it. So now I've created both link arms. Bear with me for a second here. Okay. And I want these pieces here. There we go. Okay, so I've got both link arms sketched. So I went from no link arms to two complete and correctly defined link arms in just a few minutes. And the thing that I want to stress here again is, imagine if you had to do these kinds of calculations manually. If these parts weren't together, you'd have to figure out the differences. Lots of measurements going on to do that. So the idea is just to reference both parts in their correct position and then tie them together. Now, an important difference when you're modeling in context like this is, I've built two new parts. These parts did not exist in the assembly beforehand. So it's a little bit different. In the top here, you're going to see insert and go to assembly rather than just go to assembly. And what that means, of course, is we'll automatically insert the parts that you choose into your assembly. Okay, so we'll drop those into position, and now we have Part Studio 1 showing the link arm. So again, we still have all the tabs for our separate part studios. Each one of these was modeled separately, including our layout sketch. But in the assembly, we can see those link arms. Now, it's important to point out when you do this, you're not mating it into position. These are free to move just like any other part. Anything that you insert into your assembly. Of course, you can easily fix them, but in my case, we actually need some real movement here. So we're going to grab and constrain these. All right, so we'll grab and constrain and add a few important mates to get this thing working. But again, just driving home, just because the part was modeled in the assembly context doesn't mean it's going to come in a mated orientation or fixed. It's free to move just like any other part, which means it needs to be mated with the correct degrees of freedom. All right, so I can go through, add a few revolute mates for all the rotation that this thing needs, right? And get my, kind of realistic assembly motion that I'm going for here. So now we've got, let's add this last mate. Okay. Now we've got those in position. Okay, I'll hit the green check. Now, for the sake of sketching those in, I actually created parallel mates so that I knew that the steps were flat, right? And so it's a tip. I don't know that it's something that everyone will need, but sometimes it can help to mate your part into position so that it doesn't move, and then add your contextual relationships, get it oriented correctly, I should say, and then add your correct relationships, and then I can always come in and suppress or delete those later, right? So just a tip, it can help to get that, to get your mates, your part in position, use mates, right? So now I've got that realistic open-close behavior from those link arms that we just made. Now, I have just a couple minutes, and I want to point out one last thing, and this is especially useful for InContext design. I have a shaft that goes through, that sits, this step needs to sit on, but I don't really know that position of that shaft until I assemble it, and extend it to its open position. This is another example where InContext is going to be huge, because I really don't know where it falls until I fully extend the frame and see that it's right here, right? So another example, I can right-click the step, say Edit InContext. It's going to take me into the step Part Studio, but now I can very easily start sketching, referencing that shaft, right? So we can convert, we can add, you can see I just created a new assembly context. You'll see new assembly context, a little visual cue. I can add a couple of quick lines here. All right, and we can constrain them. Okay. Make sure that we have a clean sketch. And of course, all I really want to do here is cut. So extrude, remove, all the way through all. Green check. And now I have a cut that perfectly lines up with the shaft of this frame at the open position, which is, of course, very important, right? So now when I go back, I can move this up and down and be assured that when it's in that closed position, it's going to perfectly line up with that, that crossbar. Okay. All right, so I am out of time. I know there are a lot of questions, so please bear with me. I'm going to stick around and get to all of them. I have one more quick question. Oh, before I let you go, jumping back really quickly, just to reiterate, I've mentioned most of these things already, but I wanted to reiterate them. The biggest thing that I wanted to stress is that models will update in a predictable way. You won't have, shifting parts every time you make a simple change in your motion, for example. So motion doesn't break your design, and they update in a predictable way. You update the context. You can have multiple context, just like I showed you earlier. I can have an open and closed position, and I can use them to edit a single part or multiple parts. And then to update a context, just right-click and update anytime. All right, a few last tips. I already mentioned most of these, but I'm going to mention them again. Rename your context. Rename your context is a big one. It's going to be helpful when you have multiple. Be aware of part position and hide show state when creating or updating a context. So just keep in mind, at the moment you capture that context, the moment you click edit in context, it's going to capture everything in that assembly. The hide show state of parts, the position of those parts, and that becomes pretty important. So just be aware of that when you're creating or updating a context. And finally, named positions can be a really helpful thing when creating or updating context. It just means that it's an easy way to get to a predictable position, a repeatable position, right? So these are a few tips. I know I'm out of time, so forgive me. I want to say thank you, everyone, for joining. I do have one final question for the audience. Is anyone interested in a private demo or discussion of Onshape? One of our account managers can help talk more specifically about what you do and how Onshape can apply. So if you're interested in meeting with one of our account managers, let us know. Otherwise, I will say thank you, everyone. Again, I know there are a few questions. I'm going to stick around and answer all of them, so bear with me. But I want to say thank you, everyone, and have a good day.